Hello friends, welcome to Kickstart Instrumentation. In this video, I am going to explain you some basic things that everyone should know before they start doing the PLC programming. The previous video, I have explained you how to do the hardware configuration, and now I am going to continue from this hardware configuration that I already finished with. Okay, if you see here, I have chosen this interface module 1, and here one DI, one DO, one AI modules are connected in this interface module, and it's showing one I address and one Q address. So I address means input address, Q address means output address. So for the digital input, it says the input address 0 to 3, that means 0, 1, 2 and 3. So this digital input module occupies 4 bytes. So here you should know some basic knowledge of byte, bit, word, dword and so on. Okay, so here byte 0, byte 1, byte 2, byte 3. It has 8 bits. So each byte having 8 bits. Always the Siemens PLC will start with 0. So 0 byte is having bits 0, 1, 2, 3, 4, 5, 6, 7, which is altogether 8 bits. So byte 1 is also having 8 bits. Byte 2 is also having 8 bits. Byte 3 is also having 8 bits. So all these bits combined to give us a digital input module. So that is 32 bits. So the digital input module that we have chosen is 32 channel. See here, DI 32. It has a 32 channel which occupies 4 bytes, which in terms we can say it as 32 bits. Okay, now we will see the digital output. It is occupying Q address. So why it is again starting from 0 to 1? So it clearly indicates I address is totally different from Q address and vice versa. So again it is starting from the 0. So this digital output module occupies 2 bytes, 0 and 1, which means it occupies 8 plus 8, 16 bits. So that's why you see here digital output, it is a 16 channel output module. So the digital input and digital output, why it is occupying only bits? Because it will be either 0 or 1. In other words, true or false. Okay, let us go to the analog input module. Here it is starting from 512 ending at 523. Why it is so much number of bytes occupied by this module? Okay, let us go here. 512, 527. So altogether how many bytes? It occupies 16 bytes. So let us check. It is a 8 channel module, but it occupies 16 bytes, which means each channel occupies 2 bytes. So 2 bytes is equal to 1 word. So that means each channel occupies 1 word address for its operation. So the analog input module as well as the analog output module, each channel will occupy 2 bytes, which is 1 word. So these are all very basic stuff If you want, you can read the idea of byte, bit, word in my article, which I have given the link below the description. Let me close the hardware configuration and I will go to the CPU1 and block. See here there is OB1 and here I don't find anything else. In the future you will see so much of things coming in this area. So what is this OB1? OB1 is the only block that will be executed by the PLC program. So whenever the PLC is executing the logic, it will execute the logic that are present in OB1. Even though I told you there will be so many things will be coming in this area, even though we have 100 or n number of functions, UDTs, data block, function block, so many things will be coming here, but nothing will be executed, only OB1 will be executed. So let us open the OB1. Let us give OK. So this is the main OB1 cycle and the first network. So in this network I am just going to give you a very basic idea of ladder logic. So in this I am going to add one NO contact. So I added one NO contact is here. You can also use function 2, you can use the shortcuts, and here I want to give the address. So now the digital input module, it's starting from 0 byte. So I am going to give here I means input address, 0 is the byte, and 0 byte it starts from 0 bit dot 0. Okay, so this is the first byte and first bit of that particular byte I am using. So I am also going to connect one output device. So output is here and I am going to give output address Q 0.0. Okay, now I have written very basic ladder logic, one input and one output. Let us say this is a switch. When I turn on this switch, this light will be turned on. Now I want to simulate and check. First thing, we have to download this one to the PLC. So now which one is the PLC? So I have a PLC simulator. So first I want to open that PLC simulator. See, if you see here this icon, this is the simulation on off. If you click this one, it will open the PLC simulation. Okay, now I have to download this to I have to download my OB1 to this simulation PLC. Okay, how I have to do? First thing, before we download, let us see and check. I have already selected PLC simulation TCP/IP, which is the simulation PLC that I am going to use. So let me open setting PGPC interface and make sure that it is selected PLC sim.tcp/IP1. For the real PLC, it will be connected with Ethernet and it will be shown here somewhere. And when you connect the real PLC, that's how we have to choose. So now I am going to use the simulation. That's why I have selected this one. I give OK. So it is already here. Okay, I am going to the main OB and I am going to download. Hope it is downloaded. If you want, you can also go to the main simatic manager and select the simatic attestation and select this download. It will ask which CPU you want to choose and download. So it's downloaded. The block learning simatic is being processed by another application, another user. Do you want to continue the function? Yes. Okay, now I have downloaded. Let me open the. Okay, Now I am going to run the CPU. Yes, the CPU is running. Now I want to check this one in online. So you click this monitor on off. So the monitor is on now. See, you are getting the green color icon which is showing it is running. Okay, now I 0.0. So the byte 0, bit 0 is false. When it becomes true, the output will be activated. So I am just checking this byte 0. See here, the output byte 0 is also activated. Even in the OB1 you are able to see that everything is in green. So this is the very basic understanding of ladder logic, but we want to develop step by step to make it much useful. So what I am going to do, I am going to introduce the concept of latching. So what is latching? This input is true, the output will be activated. I am going to use the same output Q 0.0 as my input. That will always make Q 0.0 to be active, as long as I have one more external command that will make this output to be false or 0. So why this one? Even though this input 0.0 is false, this output itself make the output on at all times. Okay, so that is how I taken this and I given it here. So how we have to read this ladder logic? If I 0.0 or Q 0.0, then the output Q 0.0 will be active. Okay, let us download this to the PLC. Let us try to simulate and check. Yes, I am able to monitor. Now let us uncheck the input bit 0 and output bit is also 0. Okay, now I am going to make the input I 0.0 to true. So when I make this one as a true, it will drive the output to true. Let us see that one. See, when I check input 0.0, the output QB 0.0 is active. Now even though I make I 0.0 false, the output still remains true. Why? Because the output itself drives its own operation, and that is the beauty of latching. So this latching also can be explained in other way, that is set and reset. Okay, before we go to set and reset, how this output will be turned off now? So for that we need one external command. So where with that command will be coming to turn it off? So that is a stop command. Let me stop here. So what I am going to do, I am going to add one NC contact which is normally closed, and I am going to choose it as I 0.1, that is the second bit of byte 0. Let us see how it is practically applied. So let us run the PLC. Let me also monitor. Okay, now first I am going to make I 0.0 to be true. So the Q 0.0 is also true. Now I am going to make IB 0.0 to false. Even though it is false, the output is still true. Now I am going to check I 0.1 to be true here in this PLC. That means I am going to check in. So when I check in this one, the output will go. Why? Because it is already NC. When I give the signal, it is going to become NO. That's why the output is turned off. Since this output is turned off, the same output here also will go off. Thus the total signal going to the output will be turned off. So this is the latching, and I am going to explain you this one, the same latching as the concept of set and reset. Let me stop the PLC. Let me also turn off the monitoring. Okay, so to set and reset, I am going to choose this empty box and I type yes and give enter. So this is set. So let me give Q 0.0 as its address. Okay, then I am also going to insert a new network, function F2, I 0.1, I 0.1. I am going to insert one empty box and type R for reset. I have to give Q 0.0 because I am going to set and reset the same bit. Okay, how this is going to work? Let us download this to the PLC. Okay, now I am going to set I 0.0 to be true, which is setting the output Q 0.0. Now what I am going to do, as long as I give one external signal, it will not be reset, it will be on. So the output is on. Now I am going to give I 0.1 to be true, which resets the output Q 0.0 to be false. Okay, but this here you see both the input 0.0 as well as I 0.1 are active, but the output is always remaining same. It should come true and go to false, right? Why? Because the PLC will start from network 1 and go one by one network and read the logic and execute it. So it will not take very much long time to execute one network. So it is just fraction of second, it will execute the first network and it will go to the network 2. So actually, as I told you, first it is executing network 1, which means it sets this Q 0.0 to true, and within fraction of second it goes to network 2 and resets it. That's why we are always seeing the reset as our output. So this is another way of doing latching, like set and reset. So this is a very basic idea of ladder logic. So from next video onwards, I am going to start with a proper understanding of a project way of doing some PLC stuff and ladder logic. Let me meet you in the next video. Thank you, friends.